Okay, today and tomorrow we're going to be working on the word problems in this packet. Okay? And then Wednesday we'll be going over the test review. Thursday we'll be doing a test review, and Friday is the test. Now remember, this is not a brand new test. It's a continuation of the test you already started. Okay, you already did the first 10 questions. You'll do 11 through 20 this Friday. Alright, today we're going to be working with exponential word problems, so that means tomorrow there'll be logarithmic word problems. You may use the following formulas to answer the questions below, but instead of using this one, we're not going to use it, we're going to use this one. A equals P parenthesis 1 plus R divided by N parenthesis raised to the N times T power. And we'll talk about what all that means in a minute. Okay, the original formula was a formula for continuously compounded, but we're not going to be doing those types of problems for this test, so we're going to be using this one instead. Alright, number 1. You have inherited a diamond tennis bracelet from your mom on your wedding day with an appraised value of $9,875. The appraised value has increased 3% each year. Okay, so the first thing you notice is that all three of these formulas start with A equals. And then following that, all three of them have a P. P is initial value or starting value. So what number would we plug in for P in this scenario? Right, the value of the bracelet the day you inherited. Okay, now, what's going on with this bracelet? It's increasing in value. So would we use 1 plus or 1 minus? 1 plus. What is the rate? 3%. How do you write that as a decimal? 0.03. And then, you know, it's to the T for time. Did they tell us an amount of time so far? No, so you just leave it T. Right, that would just be like if they were just asking you on the test to write the equation, that would be the answer. Now, you could go ahead and simplify this equation to A equals 9875, and then instead of writing out 1 plus 0.03, you may see it like that instead. They go and add it together. Okay, what will the necklace be worth when you pass it on to your own daughter on her wedding day 25 years from now? So what are we going to do? Right, you're just going to replace the T for time with 25 because years is time. So it'll be A equals 9,875 is how much the bracelet was worth the day you got it, but it's increasing at a rate of 1.03, and so that means 25 years later it will be worth how much? What did you say? I think it runs to 6, doesn't it? Okay. Now I want you to take a minute and try 3 and 4. Before I just go over them for you, try problems 3 and 4. You purchased a Dell laptop in 2007 for $689. Since technology is ever growing, your laptop depreciates 18% each year. So the first thing they want you to do is write the equation to represent this. So what did you write? Right, 1 minus because it's losing value at a rate of 18%, and then each year, but right now we don't know for how many years, so you put T. Now you could have also written that as A equals 689 times what? 0.82, because 1 minus 0.18 is just 0.82 to the T. Those are the same thing, it's just they actually subtracted it and got 0.82. Now they want to know how much is your laptop worth now, so what would you do? You plug in a 10 for T, because it's been 10 years since 2007. So A equals 689, and then I'm just going to use this one, times 0.82 to the 10th power. And so how much is it worth? Right, like about $94.70, if anybody would even pay you that. Okay, you recently opened a savings account with $4,500. The account is set up to earn you 5% annual interest. Find the account balance after 30 years if the interest is compounded annually. And then the second one, we're going to change from continuously, because like I said, we don't do that for this test. So we're going to change it to monthly. Okay, first let's talk about annually. It'll be A equals, what goes in your P? 4,500. And then is it 1 plus or 1 minus? 1 plus what? Right, so since I'm kind of limited on space, I'm going to go ahead and add that together. 1.05. And then to the what power? Well, this time though they give you an amount. 30 years. So now calculate that and tell me how much will be in that account after 30 years if it's growing 5% per year. Right, $19,448.74. Okay, now they want you to look at the same account, but instead of it being compounded annually, which means one time a year, it's compounded monthly, which means how many times a year? 12. So it'll still be A equals 4,500 because that's what you started the account with. But now you have to use this other formula because since we're compounded monthly, you'll plug in 12 for N in both places because it happens 12 times. When it's just annually, think about it. It would just be a 1 and a 1, so that's why it's not necessary. So it'll be 1 plus the rate, which is 0.05, over the number of times it's compounded, which is 12, and then raised to the N, which is 12, number of times compounded, times T, which is 30. Okay, so the only difference between the two is since this one's compounded monthly, that's 12 times. So you have to divide the rate by 12, and you have to multiply the years by 12. Because it's not just going to be compounded 30 times, it's going to be compounded 30 times 12. This one is pretty much the same thing. It would have just been 0.05 over 1 and then 30 times 1. And we all know that dividing by 1 and multiplying by 1 doesn't do anything, so that's why you don't have to have it. Okay, now let's talk about how to type this in case you don't know. 4,500, open parenthesis, 1 plus, it's a fraction, so we can do alpha y equals n over d, and then the numerator is our rate, the denominator is how many times it's compounded, and then the exponent is how many times it's compounded times how many years it will occur. And you get $20,104.85. So it really benefits you if this is an account where you're making money for them to compound it more often. You make a little bit more money. Okay, I want you to try 7 and 8. A population of 3,400 bacteria is growing at a rate of 4% every day. After 35 days, how many bacteria will there be? Okay, so for your equation, you should have got A equals 3,400, so that's the starting amount of bacteria. They're growing, so it'll be 1 plus 4% is 0.04. So right there, you could have gone ahead and just written 1.04. And then T for time, they tell us 35 days. And so how many bacteria are present after 35 days? I got 13,416.70. Did you type in 3,400? Look at what you typed in. Make sure you didn't like accidentally add a 0 or something. Okay, number 8. If you deposit $1,200 into a savings account earning 7% annual interest, after 5 years, how much money will you have in the account? So A equals, you're starting with $1,200. The account is earning, which means you're increasing, so plus 7% is 0.07, so you can just go ahead and combine that to 1.07, and then 5 years, And so how much money are you going to have in your account after 5 years? So what you got? Okay, number 9, I'm going to switch up the wording for this one. If the above account is compounded monthly instead of annually, how much money will you have after 5 years? So now try that one, but keep in mind it's compounded monthly. If the above account, so the same question from 8, is compounded monthly instead of annually, how much money will you have after 5 years? So for this one, everything's going to start out the same. You're still starting with $1,200. You're still adding money to your account because it's earning interest, but it's compounded monthly. So this rate of 0.07 will be divided by 12 because it's going to happen 12 times. And then the exponent is not just going to happen for 5 years, it's going to happen 12 times every one of those 5 years. So technically 60 times, right? It's going to be compounded. And so how much money will be in that account? Right. Okay, go ahead and try number 10. The population of frogs in the pond on campus is estimated at 1,200. If the population is decreasing by 10% each year, how many frogs will there be after 2 years? Okay, so we start with 1,200 frogs. They're decreasing, so 1 minus by a rate of 10%. So you could also have written that as 0.90, and then to the 2, to the second power for 2 years. And so how many frogs are there after 2 years? Right. Okay, tomorrow we're going to move on to logarithmic, and we'll also start the review sheet. Like, you'll start it by yourself. So for the remainder of today, until I say that it's time to switch out, you need to look at your pink sheet and make sure you have both stamps. Okay, there's only 2 stamps, which means they're going to be 50 points each. So if you don't do one of them, that's automatically a 50. Okay, so you should have 2 stamps. If y'all got 3? First period only had 2. Okay, then this class may have had 1 extra assignment, so 3 stamps. What are the 3 assignments? 12, 13, and 15? Okay, so you need to use this time to get that done because those are due Wednesday.